start with your questions, anything you have for me, and then we'll go to that list. I'm ready. Please remember that all web assign has to be completed by Sunday night. Thank you so much. Many of you have completed it, or they're very close, which is great. Okay. So, first question. If no questions, then we go to this. Okay, my first question is number 3 on 82, which is in section 2.1. So we're looking at 3. If we completed 3, we may have, then we can move on. So you can go back to, if you remember, if we did this problem together. We may have. I think we did. So please talk to me, anybody, please.
Yes, that was one of the ones.
Okay. Okay. Do you feel like working on another problem from these or not?
Yeah, I'd still like to practice another one, but that one is one that we
okay, we did that. Good. Okay, fine. So did we do 4?
I don't recall.
Okay, so let's work on 4 then. Same thing. No difference. Okay. So in 4 we have a point. So this is 4 in 2.1. 0.5 comma 0. Okay, and we have y equals cosine pi x. Fine. If q is the point, of course, q will be x comma cosine pi x. Find the slope of the secant line PQ. And of course, when I'm given something like this, I will definitely put them in the correct order. This is not the correct order. So the smallest is 0, the largest is 1. So I have to have 0 on the left and 1 on the right. And then I will put here the slope of PQ. Okay, so in the correct order, good. 0 is first, then 0.4, then 0.49, then 0.499. Yes. Then, of course, I'm going to leave some space for 0.5. And then I'll continue. MPQ. The next one is 0.501, 0.51, 0.6, and the last one is 1. So in order to determine, please don't write 3 pages on a problem like this. It's up to you. I accept it. If it's correct, it's correct. But there is no need to do something like this and enter it one by one and calculate one by one. No, we don't want to do that. Let's move on. So first of all, I have to present MPQ.
I'm sorry, could you just move the paper down just slightly?
Yes.
Right there. Yep. Thank you.
So can anyone give us MPQ? The slope of PQ. So we can write it here. We have a lot to accomplish tonight. So please, can anyone give us the slope of PQ? You have the points. I'm sure everyone can give me the slope.
Cosine pi x. Oh, well, we wouldn't have to put the 0.
Correct. It should be minus 0. Very good. Over?
Over x minus 1/2.
Excellent. 0.5. Excellent. This is what I'm going to enter in the graphing calculator. And then I will get all these at once. So let me share my screen. Do not calculate one by one. It's a waste of time. There is no point in doing what I saw in your homework, please. So first of all, because we are using sine, cosine, tangent, whatever, trig functions, make sure that the mode is in radian mode. Let me explain for a second. If I have cosine x, and if I plug in pi over 6, or I plug in 30 degrees, who cares? The answer is the same. But if you have something like x cosine x, you can no longer plug in degrees. So if there is any x other than inside a trig function, you can no longer use degrees. So please make sure that all these calculations are based on calculator being in radian mode. If it's alone, who cares, right? If it's just a trig function. Okay, so in y equals, since I have only one term at the top, I have cosine in parentheses. Here's your pi under the caret, and x, close the parenthesis, divide. If you don't put the denominator in parentheses, you will not get anything. I'm not saying you're going to do something like that, but I'm just talking, I guess, to hear myself, because just to make sure that there was no glitch. So then I go to second and table, and I just punch in 0. I punch in 0.4, then 0.49, then 0.499, then 0.501, and then 0.51, then 0.6, and then 1. I recorded this, and it's recorded in the module, in the lecture notes. So you can always go back and review those steps. So I'm going to copy then -2, -3.09, -3.14, 1, -3.142, -3.142 again, -3.141, -3.9. I think I skipped something. 0.4, that's correct. 141, 142. Okay. Yeah, of course, because I didn't mean to write it here. Okay. I can't write anything under 0.5 yet. So 4 point, okay, that's 2. And then 0.4, oh yeah, 1.41. -3.141. And then under 0.6, -3.09. And under 1, we have -2. So, of course, we got the slopes of all secant lines in one line, not one by one to take us 15, 20 minutes. It took us 3 minutes to do this. And now we're asked to determine the slope of the tangent line at 0.5. So what I would do is write 0.500000001 if I want to convince myself at where it's that going. It's too much for the calculator, it cannot handle. So 0.499999, let's see. Okay, so it gave us the best that we can really get, -3.1416. As you see, it makes no sense. At 0.5 is error, and then 0.5 again. But it couldn't handle too many zeros above 0.5. But it handled the 0.499999999. So maybe if I stop at, 0.500001, maybe that will not give us an error, but it has to give us the same answer. And it does, with a better approximation, I guess. I know this is a better approximation. So that's what it is. It's the same thing. So then I will say the slope at 0.5 is -3, the tangent line, 1416. That's the best I can get. And then when we go back to the book, it says, using the results, guess the value already did. Using the slope, find an equation of the tangent line to the curve at that point. Sketch the curve to the two secant lines. That's okay. Okay, so let's find the equation. So I have the slope, negative 3.1416, and I have the point 0.5 comma 0. So then I have y minus y1 equals the slope times x minus x1, where the slope is this, negative 3.1416. 0.5 is x, and 0 is y1. So then y would be negative 3.1416 x minus 0.5. And that's the equation of the tangent line.
So there you rounded to 4 decimal places. Would we be told where to round to? Because I think in the homework for this section, it specifically said like 6 decimal places.
Yeah, but if I only have 4, I only have 4. Right, for the one that we estimated, we only got 4. You can use 6, but you have to look at the other one. But this is good enough. Okay, any questions on this problem? Any questions on this problem? So this problem should not take more than 5 minutes at the most. Okay. Then I have a 7 on 92. I'm assuming that that is the next section. If not, I'll look and find it anyway. 7 on 92. Okay, so 7 on 92 is just we're given a graph and we have to answer some questions here. So I'm going to ask you for this function whose graph is shown, find a number a that satisfies a given description. Let's say the limit of g of x as x approaches a does not exist, but g of a is defined. Let's find a. If no one answers in 10 seconds, then I have to name someone.
Would g of a be, or g of a equal 4?
Yes. G of a is, a is 4 because the function exists, the function value exists, but the limit does not. Awesome. Okay, let's choose another. Limit of g of x as x approaches a from the left and from the right both exist, but the limit from either side does not. So the limit from the left, the limit from the right, they both exist. It doesn't say that they are equal, but the limit from either side does not exist.
I'm getting a equal 5.
So you said
that's what I originally was going to say as well.
Well, so I first
still exists.
Yes, so I would say
2, it doesn't.
At 2, the limit from the left exists, the limit from the right exists, but from either side does not. At 4, the limit from the left exists, the limit from the right exists, but the limit from either side does not. But at 5, the limit from the left exists, the limit from the right exists, and the limit from either side exists as well. Because that is a removable discontinuity. So
we just wouldn't be able to evaluate.
But we don't care. When we talk about the limit, we're not evaluating.
Right.
It is confusing.
That was the first one that I was going to say as well.
Yes. So it is confusing because in some limits we plug in, but it doesn't mean that we expect the function, that the two concepts are the same. They're not. So at 5, the limit from the left exists, the limit from the right exists, but as well as the limit from either side exists. So both 2 and 4 fit, but 5 does not. Is that clear? Very good discussion here. Is that clear?
Yeah.
Okay, perfect. Okay. Limit from the left, no, limit from the right equals the function value. But the limit from the left does not equal the function value. We already discussed this one. Which point will that be? So the limit from the right exists and also equals the function value. But the limit from the left does not equal the function value. Mason, what do you think?
Is it 4?
Oh, awesome. That's it. Excellent. Great job. Okay, moving on. You can always stop me, please. Okay? You can always stop me and say, we want to see more or something, something, something. Any point in time. Okay, we want to look at 11. What did I choose? 11. Oh, yes, of course, a piecewise defined function. That is a must. Okay, let me copy it. I'll stop sharing, I promise, and we'll work on it. I don't think we graphed 11. If you say yes, we graphed 11, then we'll choose another. Did we graph 11?
I don't believe so.
Okay, so
I
let's.
think we need one similar, but not one with a natural log.
Okay, awesome. Okay, very good. So let's graph this and answer a few questions. Okay, perfect. It is not a good example. I wrote myself a note, do this and also differentiate. It's not a good example for differentiation because we have not learned how to differentiate this function. We have not learned how to differentiate this function yet. So I will graph this one, but when it comes to differentiation, I have to change the function. Sorry about that. Good. So please remember the first, page 3. Please remember to present this as negative infinity 0, to present this as 0, 1, and to present this as 1 to infinity. And then start the table. Please, please, please. Notice that the domain of this function is, Tom, what do you think the domain of this function is?
All real numbers?
Brilliant. Thank you very much. So in the table, I have to have 0 and 1. Mandatory. I can put whatever else I want, but 0 and 1 must be in the table. And look at these symbols. A bracket to the left and a parenthesis to the right. Also here, a parenthesis to the left and a bracket to the right. Parenthesis to the left and a bracket to the right. Then I make myself write this again. You can say, you have it up here. True, I do. But sometimes they may not be presented in the correct order. And I may plug in the wrong function. So I'm going to write them again here. Between negative infinity and 0, e to the x. Between 0 and 1, x minus 1. And between 1 and infinity, natural log x. Now I will plug in some points here, some points here, some points here. I mean, plug in x values to find points. So first of all, I plug in 0, and I get 1 right here inside the bracket, which means this will be a full point. When I plug in 0 here, I get negative 1 inside the parenthesis, which will be an open point. So full, open. Why? Because they're not the same. Okay, I plug in 1 here and I get 0. I know I have to come back to that in a moment. When I plug in 1, does anyone remember natural log 1? Natural log 1.